All right, so this is page 7 in the honors packet. It's on rationalizing the denominator. And if we start with the Spark Your Learning, we see that we have something that looks like this, and it turns into something that looks like this. We have something that looks like that, turns into something that looks like that. Right, this is equal to that. If you have a calculator and you want to plug in all these numbers and the decimal equivalent, you'll see that these are the same thing. And same with these. And the question is, what's different, right? What changed between here and here, and here and here? Well, and the answer is that this one started with a radical in the denominator, and it ended with a whole number in the denominator. Same thing over here. Started with a radical in the denominator, ended with a whole number in the denominator. So this process of rationalizing the denominator just means we're making it so that the denominator, the bottom of the fraction, doesn't have a radical in it. Okay, so if we jump down here to rationalizing the denominator, to be fully simplified means that there is no radical left in the denominator. Sometimes this can occur with dividing. The process of eliminating the radical is called rationalizing the denominator. So this is just saying that we're going to start with something that has a radical in the denominator, and we're going to manipulate it in some way so that there is no longer a radical in the denominator, right? So the denominator is a whole number like you see here or here. And why might we want to do that? Well, it makes performing operations easier. Because, for example, if you had like two things like this, like let's say that you were trying to add this term to this term, the denominators would be very different, and so you wouldn't be able to add them. And because they're radicals, the process for finding a common denominator is not going to be straightforward. But if they're both whole numbers, then it's essentially like adding a fraction, in that you can just find the common denominator between the two fractions and add them that way. So all of that's really high level of just why do we want to rationalize it? Just because it makes calculations easier, right? It makes it easier to add, subtract kind of terms that have radicals in them. And we're not going to be doing a lot of that like in this class, but this is a skill that if you go on to pre-calculus, which all of you guys in honors intend to do, um, you're going to need to work with kind of these types of um, these types of terms a lot more often. So we're building this skill now. And we have two kind of different cases that we can work with, right? We can have a monomial or a binomial. And in a monomial, right, to rationalize the denominator in a monomial, I guess before we get there, um, what is the difference between a monomial and a binomial? Well, with a monomial, you see the denominator just has one part of it, right? It's just square root 12. Over here, it's 6 plus the square root of 5, right? You have two different parts in the denominator. You have a 6, you have a square root of 5. So monomial, mono means one, right? Like monochrome, monotype, mono, one. Binomial means two. Bi means two. So monomial has just a single term in the denominator, binomial has two. We'll start with the case where we're simplifying a monomial. And to do that, we can get rid of the denominator by um, multiplying the numerator and the denominator by the radical. And to rationalize a binomial, we have to multiply the numerator and the denominator by something called a conjugate. We'll do examples of all of these. So if you're just filling this in for now, that's okay. It'll make more sense in a minute. The conjugate is the same expression, but with the opposite sign in the middle. So if our binomial denominator was 3 plus the square root of 6, the conjugate would be 3 minus the square root of 6. All right. So how are we going to do this in practice? Here it's saying the first step is to simplify the radical in the numerator and the denominator, and then simplify any terms that you can, like anything that you can cancel after doing that, go ahead and do that first. And the reason why that's a good first step is because sometimes you don't even need to do the multiplication step. Sometimes it'll just simplify through division and you can be done. So let's start with this example and see what happens if we simplify the numerator and the denominator. Well, the numerator is the square root of 80. We're going to say that's the square root of 16 times the square root of 5. You can also do the factor tree way, but I'm going to take the shortcut at this point. So that's 4 root 5. Then the square root of 12, say that that's equal to the square root of 4 times the square root of 3, or 2 times the square root of 3. So our term here, square root of 80 over the square root of 12, would become 4 times the square root of 5 over 2 times the square root of 3. Like I said, at this point, we can simplify anything that we can. So we see that we have a 4 on the numerator, a 2 in the denominator. We can divide both of those by 2, and you can get 2 square root of 5 over square root of 3. All right, so that's this first part here. Just simplify the radical in the numerator and the denominator and see if you can cancel anything right away. Here we could cancel a 2. Once it's fully simplified, then we rationalize the denominator. And by that, we're going to go up here, right? This is saying to rationalize a denominator in a monomial. We know we have a monomial because there's just one number in the bottom. Multiply both the numerator and the denominator by the radical in the denominator, then simplify. So over here, where's our denominator? It's root 3. So to simplify this, we can actually just multiply the numerator and the denominator by the square root of 3. If you notice, square root of 3 over the square root of 3, that's equal to 1. So we're not changing the value of this equation, right? We're multiplying, or of this term. We're multiplying it by something that's equal to 1. So it's going to keep the same value, but it's going to look different. Right? When we're multiplying fractions, we can just multiply across the top, multiply across the bottom. We multiply across the top, 2 times the square root of 5 times the square root of 3. Well, that's 2 times the square root of 15. You can just multiply everything on the outside of the radical, everything on the inside of the radical. And we want to divide that by the square root of 3 times the square root of 3. The square root of 3 times the square root of 3, well, that's just 3. Right, that's essentially going to become the square root of 9, and the square root of 9 is 3, so those two will combine. And so here we can see that we have successfully rationalized the denominator, right? We no longer have a radical in the denominator, right? This is a whole number, that's what we want. Importantly, you might not be done at this step. For some problems, you then might need to simplify this radical in the numerator again. The square root of 15, that's as simplified as it can get, so we're done with this one, but just as a heads up that if this were something that could be simplified further, you would need to do that. Okay, so before we jump into the binomial, let's do 2 more examples of the monomial. So our first step is to simplify the radicals in the numerator and denominator. Here, we just have a 2 in the numerator, so we don't need to simplify anything, and the square root of 6, we can't simplify that any further. You can only break that up into 2 times 3. We don't have a pair of any of the numbers, so we're good. So now we can go on to our next step, which is to multiply numerator and denominator by the square root in the denominator. So here we would do times the square root of 6 times the square root of 6, and that would then give us 2 times the square root of 6 in the numerator. 6 square root of 6 times the square root of 6 would give us 6 times, we still have that 5, right? So essentially this 5 goes there. 6 square root of 6 times square root of 6 becomes 6. And so at that point, we would have 2 root 6 over 30. And we can simplify that, right? We have what goes into that, right? What goes into 2 and 30? Well, it's 2. So our final answer would be the square root of 6 over 15, right? Essentially simplifying it as if this were like its own fraction. Okay, moving down here. For this one, I do want to simplify this numerator further, right? 3 times root 12. Well, that's 3 times the square root of 4 times the square root of 3, right? That's what square root of 12, right? 3 root 12 is going to equal to 3 times those two. The square root of 4 is just 2, so we can change that to a 2. And then 3 times 2 times the square root of 3, 6 times the square root of 3. So all of this was just looking at the numerator, right? Our first step here, simplify the radicals that you see. And now that we have that, we can rewrite this as 6 times the square root of 3 over, our denominator stays the same, 4 times the square root of 7. All right. And we can actually simplify that further too. You see we have a 6 and a 4, so that can turn into 3 square roots of 3 over 2 square roots of 7. Okay. Now we want to rationalize the denominator, right? Now we want to do this step where we multiply by square root of 7 over square root of 7. And the reason why we want to do that is because the square root of 7 times the square root of 7, that's going to give us a whole number, right? That's going to give us something in the denominator that doesn't have a radical. So on the top, we're going to have 3 times the square root of 3 times 7, so 3 times the square root of 21, divided by 2 times the square root of 7 times the square root of 7. That's just going to be 2 times 7, which is going to be 14, right? These two square roots are going to become a whole number. 2 times 7 will give us 14. And this is our final answer. All right, we can see we can't simplify anything further here. The square root of 21 is as simplified as it gets. If you wanted to check that, you could do your factor tree, break it up into 7 and 3. We don't have any pairs, so we can't do anything more with that. Okay, so now we need to return to the binomial case. It's where the bottom is 6 plus the square root of 5. For this one, we have to do something called the conjugate. And so right away, I'm going to see I can't really simplify anything further here. Square root of 5 is as simplified as it gets, so I'm going to go right to the next step of multiplying by the conjugate. And how this is going to work is we're going to do just 2 over 6 plus the square root of 5 times the conjugate. And importantly, you need to multiply both the numerator and the denominator by the conjugate. So the conjugate of 6 plus the square root of 5 is 6 minus the square root of 5. Okay? And so you might be wondering, why are we doing something like this, right? Where this conjugate term is kind of weird, where is it coming from? You'll see in a moment what it does for us. So let's start by just working with the top. Right? Essentially, we have a number times two things in parentheses, so we can distribute across. So on our numerator, we would have 12 minus 2 times the square root of 5. Okay, now in our denominator, we have to do a little bit more work because we have two different terms going on here. And so this is where you need to essentially double distribute. So we have this second term, and we need to multiply this times that term and this times that term. So we're going to have 6 times 6 minus root 5 plus the square root of 5 times 6 minus the square root of 5. All right. Yeah, I apologize. This is going to take up a little bit more room. Make sure I'm getting everything. There we go. So in the denominator, So the numerator is going to stay the same. And then for the denominator, just to make it maybe a little more clear to see what happened there, we did that. And so the denominator is going to become 6 times 6 is 36 minus 6 root 5 plus 6 times the square root of 5. And then square root of 5 times negative square root of 5, well, that's just going to be minus 5. This is slightly messy here. Change, rewrite that. That's just square root of 5 minus 5. Okay, so now we can see why multiplying by the conjugate is helpful. Because essentially, if we multiply 6 plus the square root of 5 times 6 minus the square root of 5, the radical terms here are going to end up canceling out, right? When we have this plus 5 times this plus 6, we're going to get positive 6 root 5. When we do this 6 times this negative root 5, we're going to get minus 6 root of 5. So those two are going to cancel each other out. Actually, I don't want to do it that way, but just these two are going to cancel each other out. So you're going to be left with 12 minus 2 square roots of 5 over essentially 36. Essentially 36 minus 5, which is 31. Now let's do one more example of this. So I know that it is slightly more involved than other things that we've been doing. So right away, we can't simplify anything here. We have nothing we can cancel. Square root 7 is as simplified as it'll get. So 3 times the square root of 7 over 2 plus 2 root 7. We're going to multiply that by 2 minus 2 root 7 over 2 minus 2 root 7. Okay. So our denominator, we're just going to be able to distribute. And so we're going to have 6 square root 7. And that comes from essentially this term times that 2. And then we're going to have minus 6 because of the 3 times the 2 here. But then we're going to have the square root of 7 times the square root of 7. So that's going to be times just a 7, right? Not a square root. When you do square root of 7 times square root of 7, you get just a 7. Divided by, now we have to do our double distribution again. So, right, put those like that. Like highlight that term. I'm going to have 2 times 2 minus 2 root 7 plus 2 root 7 times 2 minus 2 root 7. Of that and there. Multiplying this first term times here, and this first term times that. Okay. So now we want to clean this up a little bit. So we have 6 root 7 minus 6 times 7, that's going to give us 42, over, now we need to do our distribution there, and our distribution there. So we're going to get 4 minus 4 root 7 plus 4 root 7 minus 4 times 7. Right here, that last multiplication, 2 root 7 times minus 2 root 7. So you're going to have minus 2 times 2 is 4, root 7, 7. Okay. And so here again, actually, we're just going to say this 4 times 7, that's negative 28. I can simplify that at that step. And now we can notice that these two are going to cancel each other out, right? You have a plus 4 root 7, you subtract 4 root 7, they cancel out. So the result, 6 times the square root of 7 minus 42 over 4 minus 28 is negative 24. Now here, we are not quite done yet, because what I can notice is that 6 goes into 6. 6 goes into negative 42, and 6 goes into negative 24. And I don't really like having a negative in the denominator here. I think it's really nice when the denominator is positive, right? That's what we want to get to. So I'm going to divide everything here by negative 6. So we're going to simplify by negative 6. So we can get negative square root of 7. If I take negative 42 divided by negative 6, I'm going to get positive 7. Negative 24 divided by negative 6, I'm going to get positive 4. Now I'm just going to rewrite this so it's a little bit cleaner, right? You generally want to write it number first, and then plus or minus the radical over the denominator. So my final answer here is going to be 7 minus the square root of 7 divided by 4.